Alright, so in section 2.4, they put a lot of stuff in this section, so we're going to kind of take it a little bit at a time. So this video is mostly going to be the isosceles triangle part of this. Just a few little special things you can do. So remember, an isosceles triangle means that it's got two sides congruent. And so just a little bit, remember we kind of talked about isosceles triangles. The two that are the same size are called the legs. And the one that's not the same is called the base. And then this angle and this angle are called the base angles. And the angle in between the two legs is called the vertex angle. So just for that vocabulary to go along with an isosceles triangle. So whichever two are the same are the legs. The one that's not the same is the base. The angles at either side of the base are the base angles. Now, one thing you need to know also then is that the base angles are congruent to each other. Okay, so in this triangle, these two angles would be congruent. So it'll show up in proofs sometimes if they tell you a triangle is isosceles, and we can use we'll use this in our reason column. If two sides are congruent, then the angles opposite those two sides are congruent. Okay, and the other way around as well. If we have a triangle where we know two angles are congruent, then the sides across from those two angles are congruent. And it doesn't matter how it is positioned. You know, if you have this triangle here, if I tell you that these two angles are congruent, then the conclusion is that these two sides are congruent because they're the ones across from the two angles that are congruent. So we can just use that to do a few examples here. So sometimes we can use it in some stuff going on here with finding x and y in the diagrams. So if these two sides in this triangle on the left, so we're kind of ignoring this part of the picture for now, because those two sides are congruent, these two angles have to be congruent. So if that one's x, the other one is x. Triangles add up to 180. We've used up 50 in that top angle. So the rest of the 130 we know has to get split evenly, and that means these two angles are each 65 degrees. Okay, so then we can work our way, because here we have a linear pair. So if that's 65 degrees, this one here is 180 minus 65, which is going to be 115. This one is 115. And also we have another isosceles triangle. If we look at the other triangle now, and it's 115, because the two sides are the same, those two angles are the same. So we've got 65 degrees left to split evenly between those two, and y would have to be 32.5. So x is 65 and y is 32.5. Yeah, we can look at this one over here. We've got this triangle on this side is actually equilateral. When the triangle's equilateral, then it's just a special isosceles, but then all of the angles are 60. So right away we know that x equals 60. Now we can do the rest of this one the same way we just did the last one. If this is 60, this is 120. We can also use our exterior angle theorem. Okay, that means those two y's have to add up to 60. That's what's left to split evenly, and y is 30. So these would each be 30. Okay, so we're just using that isosceles triangle property. Oops, sorry, skipping around a little bit here. So again, just look at one thing at a time. I'm looking at this, the triangle all the way over here on the right. These angles have to all be 60s if they're all the same. Okay. The one on the left, if this one is 50, this one has to be 50 because these two sides are marked the same. Okay. Now where we have to go with this is we've got a straight line here, so we have to have 180 degrees for that whole thing. So with a 50 and a 60 being 110, 180 minus 110 leaves 70 there. That middle triangle is also isosceles, which means this has to be 70. So now we can figure out x and y if we use just the middle triangle. X is going to be 180 minus the 140, that's all used up. And y is going to be 180 minus the two 50s, or 80. So x is 40 and y is 80. It's kind of work one triangle at a time. This one, next example 4 over here, because these two sides are the same, then these two angles are the same. So we can write the equation 3x minus 11 equals 2x plus 11. I subtract 2x from both sides and add 11, I get 22 for x. Now, as far as finding y, we're really going to have to plug it back in. If I go to times 22 plus 11, that means this angle and this angle are 55-degree angles. So 180 minus the two 55s leaves 70 for that one. So if 2y is 70, y is 35. Now we've got some overlapping triangles, a triangle inside of a triangle. This one's kind of an interesting example. But both triangles are isosceles, if you look at the markings. Okay, this side compared to this side, and this side compared to this side, looking at those markings. So if we look only at the bottom triangle, just going to get rid of those for now again. So if we look only at the bottom, we're ignoring all of this for a minute. I've got a 90-degree angle up here. So if this is isosceles, then these have to be 45s. 45s. So 3y equals 45 and y equals 15. Okay? Now, what we need to do is pretend, let's see, can I do a white? Let me do a white and make it thick. I'm going to erase this for a minute. If this wasn't there, if that wasn't there, okay, and I've got 50 up there at the top. So we're thinking about this triangle that's isosceles with a 50-degree angle here, and we know those two have to be the same. So 180 minus the 50 leaves us with 130 to split evenly between these two. So that means these angles are 65-degree angles. Let's see if I did this to make it work. And when I put this stuff back, okay, then I can figure out that this little angle here, the 2x, if we think about piece plus piece equals whole thing, if this piece is 45 and the whole thing is 65, that has to be 20, and x equals 10. Okay, so that's kind of tricky to look at. You get a triangle inside of a triangle, things get in the way. And we have another isosceles over here. If we look only at this part of the picture first, ignoring this one, because those two sides are congruent, then these two angles are congruent, so 4x minus 10 equals 2x plus 12. Subtract 2x, add 10, divide by 2, x must equal 11. Okay, so we can plug that back in. 22 plus 12 is 34. So these are each 34. 180 minus 68 is 112 for this angle. Then because we have a linear pair here, 180 minus 112 is 68. Because these two are congruent, if that's 68, this is 68. And that leaves, for this angle here, 180 minus, that's 136, which is 44. And y equals 11. Okay? And we're going to stop there on that one, and I'll do part 2 with the